Chapter 3, Section 3. This is graphing inequalities again. Graphing inequalities. But this time we're going to be working with multiplication and division. And this is going to throw a little curve at you. Don't get too worried about it, but there's something that actually changes here that isn't the same as what we did before. Before, let's say we had 3m equals 6, and we divided both sides by 3. We're good to go, right? M equals 2. Or we did negative 3m equals 6, divide both sides by negative 3, and we'd say m equals negative 2. Notice the difference. I don't have a negative on this one, but I do have a negative on this one here. There becomes the difference in what we're going to be doing with graphing inequalities with multiplication and division. Let me explain what I mean by that. Same as what we had before. If we used 3m is greater than 6, okay, we divide both sides by 3. Since we're dividing both sides by a positive, right? We're dividing by positive, nothing changes. This works the same as what we've done before. M is greater than 2 would be your results. But the difference comes in is when we start working with negatives. All right, negative 3 divided, negative 3m is greater than 6, and we divide both sides by a negative number. What happens then is it switches our sign. M is less than a negative 2. All right? To show you how this works and why this works, if I was to take this equation right up here, and I was going to build a number line, and let's say I was going to put 1 in for m, okay? If I put 1 in for m, would that be a true equation? Negative 3 times 1 is greater than 6. Well, negative 3 is greater than 6? No, that would be a false statement. That is not true. Let's say we're going to turn around now and say in this one here, this m is less than negative 2. All right, if I put 1 in for that, is 1 less than negative 2? No, that's also a false statement. What we've done is we've taken the equation and we had to keep it consistent from what it was before. So in this case here, if we wouldn't have kept it consistent, let's say we were going to treat this just like we treat it with an equal sign, and we're not changing any signs. Let's see if these would come out the same then. If we took negative 3m greater than 6, and we put 1 in for m, so negative 3 is greater than 6, and we know that this is false, all right? And let's say we divided through that negative 3, and we actually came up with m is greater than negative 2, without switching the sign. And I put my 1 in for m here. Is it 1 greater than negative 2? Well, yeah, it is. This would be true. You see how we have been able to figure out just by putting a number in and finding out that it actually changes unless we reverse the sign when we divide through by a negative number. Let's try this again. Let's say we have negative 2m is less than or equal to 4. If we were to put a number in for that one, I'm going to draw my line graph, but if we were to put a number in for this, let's say we said m is m equals 3, all right? And we put that in for m here, negative 2 times 3 is less than or equal to 4. Is that true? Is negative 6 less than or equal to 4? Well, yeah, that's true. We know that's true. So let's go ahead and solve for m on this one. Let's divide both sides by negative 2. This might be a little confusing right now, but I'm going to clear this up because we aren't going to do this all the time. I'm just helping you I'm just showing you what's going on here. We would end up with m is greater than or equal to, remember we divided through by a negative, so we have to change that sign, is greater than a negative 2. Well, let's take that 3 again. M is greater than or equal to a negative 2, and let's put that 3 in for m again. Is 3 greater than or equal to a negative 2? Well, yeah, it is true. So we know that we're consistent. We know that we're consistent with what we're doing here, and we've done the right thing. So we can turn around and we can graph this. We can graph this one right now. We can go to negative 2, 1, 2. Since it's an equal sign, we're going to put a closed dot, and we look at what this arrow does on the greater than, and we know that it goes to the right. We've just graphed it. So what we've done is we've solved the equation for the letter, and we turned around and graphed it. Let's do one that I'm not putting all the numbers for. Let's say negative 3w is less than 21. All right, I know that I'm dividing through by a negative number. All right, so then my sign is going to change. So w now is greater than a negative 7. And then I'd turn around and graph that one on a line graph. What if we were dividing by a negative number? Let's say we had w divided by negative 3 and say it's greater than 6. Now instead of dividing through by negative 3, we're going to multiply through by a negative 3. All right? Our negative 3's cancel out. W now is less than a negative 2. I'm sorry, a negative 2, negative 18. Treat it like I was dividing. This is negative 18. Okay? 6 times negative 3 is negative 18. And we graph that. So once again, when you divide through or multiply through by a negative number, you have to switch the graph. Or switch the inequality right here. You got to switch those inequalities around so that the statement remains true.